Hi there, welcome to Mr. Morgan's Math Help for Algebra 1. We are in Unit 1 still, getting to the end of this unit, and we're on Lesson 15. Not sure necessarily if we'll do Lesson 16. Lesson 16 kind of puts it all together. It's not much of a lesson really, so this could be our last one in the unit. I'll just kind of wait and see. Alrighty, so here we go, learning goals. Let's compare statistics for data sets. And our targets, I can compare and contrast situations using measures of center and measures of variability. So at this point, we really have talked a lot about our measures of center, which are our median and our mean. And we've also talked about our measures of variability, which are going to be, when related to the median, it's our interquartile range. And with our mean, we've been talking about our standard deviation. So those are the main things we've been discussing here over the last few weeks. So we're going to be looking at those a little bit more today. So here we go. Warming up. It says each histogram shows the bowling scores for the last 25 games played by each person. Choose 2 of these people to join your bowling team and explain your reasoning. So here we have a variety of scores from 4 people, person A, person B, person C, and person D. We can see their range of scores for 25 games, and you get to decide which 2 people you would like to have on your team. So take a moment to look at those 4 data displays and make a decision about which 2 people you would like to have on your team. Let me just pause here for just a second. Again, there's no correct answer here necessarily. It's your team. You get to pick. But the key thing is to have some reasons. All right, so let's look at person A. If you were to go by, for example, some basic things like let's connect some means and standard deviation together, because mean and standard deviation are linked together. So I'm going to draw a little line here like this. So our average score for person A is 118, B is 131, C is 133, and D is 116. If you just went with averages, right, C and B have the best averages overall, okay? So that would mean on average, they do score a higher score in bowling, all right? Now, we have to look at the standard deviation though as well. While this one, C, is 133, that standard deviation of 45 is quite large, which means they could be 45 less or 45 more than 133. Whereas in person B, a deviation of 8 is pretty close. Most of the scores are going to be right around there. And in fact, when you look at its chart, most of the scores are sitting right in that range right there. That looks pretty good, okay? So just in terms of the averages, I like person B. That's a pretty strong, bowling score of the 4, okay? So probably you're going to go with B as being one of your better ones, right? So this is probably choice number 1 for me, at least. Now, in terms of choice number 2, I'd have to decide, well, where do I want to go next, so to speak, okay? I mean, person D, this high score, that's great, but the odds of them doing that very regularly are pretty small. So consistency is certainly nice, right? So having a small standard deviation is good. So consistency is great. Probably something you want to look for. If I looked over here at this guy, again, that's a pretty good range of scores it looks like from 60 to 220. That's a huge spread of scores there. If we were to consider this as an outlier, like it doesn't normally happen, and look back at this guy here, well, I guess they're from 80 to 140, okay, compared to this one, which might be more like I don't know if that's 110 to 200. So if you look overall between the ones, I would say this one's too spread for me. Even though it has a good mean, I just don't know what kind of score I'm going to get there. This guy here, A, 110 to 200, means for the most part, it's going to be somewhere in the range of probably, somewhere about here for what the scores are going to be, which is not bad. This person's kind of median type score, we know it's 103. This median's 111. I think because of what's left here, I might go with person A, just based upon the median at that point, but, hard to say. Okay, so maybe you would do B because of the standard deviation with the mean, And A, you go as your second choice because the mean is better than this one over here, if you were to eliminate that. And with eliminating the outlier. So again, no right or wrong, just talk it through, think about it, have a reason why, and hopefully the person you put on your team does a good job. All right, activity 15.2. Says all the marathon runners from each of the two different age groups have their finishing times represented by the dot plot. All right, so ages 30 to 39 and 40 to 49 with their times. Which age group tends to take longer to run the marathon? And explain your reasoning. All right, so which one seems to be longer? Well, longer means it's going to have a greater time, a larger time. So overall, when we look at the 30 to 39 range, from 380 to 460, there's basically nobody there, right? Whereas over here with this age group, we do have several people. So we'd probably go with the 40 to 49 age group. Seems to run a little longer overall because there are definitely people that took more than 330 or whatever it is, 80 minutes to finish the race, where there's nobody right here. So perhaps that's why. Now, in terms of variability with the finish times, which one has the more variability? Variability, remember, we talked before, is that spread, right? Do you see a good spread? Well, from here, we're talking about, looks like maybe 250 spread all the way out to 450. So it has a pretty good spread of about 200 data points between the lowest and the highest. Over here, we're about 230, and we're going up to 330. Oh, sorry, 380, my mistake. So that spread there is about 180, right? No, 150. So this one, the older group, 40-49, has the larger spread overall. So more likely, we would say it has more variability there than the other one, okay? Now, if you did a dot plot, you'd be able to see where exactly it's going to be, and see which one has a greater interquartile range. This one seems to have a greater interquartile range just by appearance, okay? And we're not going to work it all out, but more than likely, we'd probably say that 40 to the 49 range is probably have the most variability because of that spread, okay? So, we know how to do these things and calculate it, but the idea with the charts is that now you can analyze them. You don't have to always do all the math and the work and computation in order to be able to see which one has more variability or which one takes more time to run. You can analyze it without all the extra math stuff, okay? Because you're doing math almost mentally at this point. For each group of data sets, and we have several here, I'm going to kind of flip through. You can see we're going to do several data sets here all the way to number 7. Okay, so we're going to do 7 data sets. For each of the 7 data sets, we're going to determine the best measure of center and measure of variability to use based upon the shape of the distribution. Okay, and then we're going to see which one has the greatest measure of center and the greatest measure of variability. Okay, so for each one, we're going to basically decide, do we want to use mean or median? And then we're going to want to decide, do we use the interquartile range or do we use standard deviation? Now remember, standard deviation usually goes with the mean and medians goes with the interquartile range. And then we want to see which one, A or B, have the greatest measure of variability. Okay, so you're going to have 3 answers to each one, basically, or 4 answers, okay? You're going to have your measure of, we'll do this. You have your center, you're going to have your variability, and then you're going to have the greatest or the largest center, and then you're going to have the largest variability, okay? So those are the 4 things we're going to be trying to find out in each of the 7 data sets. All right, so for the first one, okay, we have a nice symmetric, right? And so when it's symmetrical, whether it be like this or like this, when we have symmetry, we always say that it's good, in this case here with symmetry, to go ahead and, again, we can do whichever one we want. But with this one here, because they're so symmetric, the mean and the standard deviation are going to be the best ones, okay? So I'm going to go with mean and standard deviation because they are symmetric. Okay. Now, for which one has the greatest center, we can kind of look at it and go, well, that center's about there, and that center's about there. So we have a -8 and a -10. Well, because they're negative numbers, the greater one is going to be A. Okay, so that's the greatest measure of center, because -8 is greater than -10. Okay, and then for the most variability, the spread, here we have -12 and -4. If you're looking at the standard deviation, that's how far away things are on average from the center. We can see this one goes out to, what is that going to be? Adding 4, subtracting 4. Over here, we're going down over there. Yes, it's -4 and +4, but notice how most of the values in here are centered around the mean, whereas here, around the mean, are less values. Most of the values are over here. So I would expect the standard deviation over here to be much further away from the data point. Okay, so the mean for 1A is going to be greater, and the standard deviation is also greater since the data points are further away. Okay, this is going to have a small standard deviation because things are closer to the mean. This is going to have a greater standard deviation. So we would go with for this first one, we would say, let's use the mean and standard deviation because things are very symmetrical. And then A has this greatest mean, and it also has the greatest standard deviation because values are further away from the mean than in B. Okay, so that's what we're talking through. So I did a lot of talking there. So let's look at the next one. All right, so looking at this one. Again, what I see is some nice symmetry happening here. So because we see symmetrical graphs here and representations, we would go ahead and choose to use the mean and the standard deviation. Okay, that's the first one. Now, which one has the greatest measure of center? We can simply find the measure of center because it's symmetrical. We can say, well, that's here at 20, and this one's here at, what number is that? 29, 30. So the greatest measure of center is 2B. And which one has the greatest measure of variability, the largest spread? Hopefully you can tell that this one seems to have the largest spread, doesn't it? Okay, more data points are away from the middle. This one's pretty grouped together. So we would say that 2A has the greatest measure of, larger standard deviation. Okay, so it's more spread out. Okay, next one. Okay, this one is not symmetrical, is it? Right? We're going like this, we're going up, here we're going up and down and up. So it's not symmetrical. When it's not symmetrical, what do we use? Well, we use the median and we use the interquartile range in order to figure out which one has the greater measure of center and the most variability. Okay, so now with this one here, it's a little bit harder for us to kind of like just draw a line, but it's kind of what you need to do. So for this one, we're going to use the median and interquartile range. And the median, if we take a look at it here, just kind of eyeballing it, figuring out where is about half. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So if you're looking about where are about 13 of them at, you probably draw a line somewhere around here. This is probably the same number. So if I was to take about 13, I can go, well, it's about 4, 5, 15, somewhere about here maybe, not quite sure. This is estimating the median. So based upon that estimate of where half the dots are on one side and half the dots are on the other side, this one's somewhere around 8 and this one's somewhere around 2. So we'd probably go with 3A has the greatest measure of center. Okay? Now that's our measure of center, and we're looking then at the interquartile range. Interquartile range means that I take my center value and then I go between the minimum and the median and the maximum and draw another line for dividing those numbers in half. Well, this one would be here about 1, This one's here about 4.5, and that would be my inner quartile range there. Again, just estimating this one here, right? This one's gonna be about 10. This one, it looks like it's somewhere about here at maybe 5. So drawing an estimated inner quartile range, right? We could say we're between 4.5 and 10. So 10, that's our range there. And here we're between 1 and 4.5. So this has a range of about 3.5, and this one over here has a range of about 5.5. So the greater inner quartile range looks like 3A as well, has the more variability. Now, you could look at it this way. You're again looking at where's the spread greater. Well, just look at this. From 0 to 11, pretty big spread compared to 0.5 to 5.5. So even that part there is showing you that 3A has a greater amount of spread. All right. Next one. Here we have a box plot, right? So can we still figure out measures of variability and things like that in center? Sure we can. Now, because it's a box plot, right, that means it provides us with this value right here. And that value in the box plot is the median. We don't have individual data points, so we're not able to find the mean. So we're going to use the median as the measure of center, which then also means because we already have the box plot, it's easiest to use the inner quartile range. So the measure of center here, we're on this point, which is 500, compared to this point, which is 700. So this greatest measure of center is going to be 5A, right, at 700. And then the greatest variability means, okay, who has the larger box plot, right? This is going from 600 to 900. And here we are at about, we'd say probably 450, and we're going there to about 650. So that box is about a width of 200, and this box is a width of 300. And so again, you can tell from that what the box is, but you can also tell from the inner quartile range, 200 to 700. That's a spread of 500 there. And here we're at 500 to 1100. So it's a spread of about 600 there. So depending on what you want to look at, okay, if I just look at the Q1 to Q3, this one's smaller. If I look at the whole range, this one's smaller, and that does match up over here. The reason I look at both is because of those outliers, right? That outlier could extend a box plot further just because of one value. So that's why it's hard to say. But in this case here, we could probably be all right with saying that the inner quartile range for 5A is going to be the larger one as well. So more variability for this one here. Okay? All right. All right. A political podcast has mostly reviews that either love the podcast or hate the podcast. Okay. So we have kind of two choices, right? Yeah. A cooking podcast has reviews that neither hate nor love the podcast. All right. So in this case, we don't have a graph to look at, right? So let's think about if I had things, let's make a graph. Let's do this. If I made a table like this, where 0 was how much you liked it, and 0 to 10, kind of your range of likes, okay? So this is like, no, I don't like it, and yes, I love it, okay? So if this was the one for A, where the people either love it or hate it, we'd expect to find a lot of values here, and a lot of values here, and very few values there. For B, if it's a 0 to 10, and people have reviews that neither hate nor love, they're mostly going to be in the middle, right, with only a few out here. So in terms of the shape, we're going to find the shape to be not a lot of a spread there necessarily. It probably is going to be generally pretty symmetric. Okay, so most likely, if possible, we would probably go ahead and use we can't really use a mean here. So if I had numbers and values, I would use those, but I don't have anything to say. So really, I can't use any measure of center or any measure of variability because I don't have numbers. So really, for the first one, we'd say I can't use them because I don't have them. but based upon a hypothetical, what I might think it would look like, I would probably go with those, but I can't. So in terms of the measure of center, what would I use? I would expect to see the greatest measure of center is going to be, well, they're probably going to be very similar. So I expect that I wouldn't expect really any much difference. I would probably say they're going to be very much the same because of the way it's spread out. Okay. The greatest variability, though, would definitely be the A, 6A. And that's because you're going to have a range of scores here and here. You might have a range there, but most values are going to be further away. So probably I'd go with 6A, if anything. Kind of an interesting one just to think about. I don't know. Last one. All right. A, stress testing concrete from site A has all 12 samples break at 450 pounds per square inch. Stress testing concrete from site B has samples break every 10 psi starting at 450 psi until the last core at 560. Stress testing concrete from site C has 6 samples break at 430 and the other at 460. Okay, so these guys are all breaking at 450. This one has 450 to 560, and this one has 430 to 460 is where they're breaking at. Okay, so in this case here, we can see that they're all fairly symmetric. Okay, there's not like any outliers or crazy values there. So we would probably be able to use the mean and standard deviation to solve this one there. Now, in terms of which one's going to have the greatest mean, just looking at the values, this one's going to be about 450, right? Because where it is. The mean of this would be in between, so maybe about 445. For B, we're starting at 450, which is already greater than that one. And over here, this is 445. Again, we're starting at a value greater than that one. So this one's going to have, B is going to have the greatest measure of center, for sure. Okay? All right, just from based upon where that is. And now, in terms of standard deviation, the larger spread, this has 0 standard deviation, is all the same. This standard deviation, you have a spread of about 30, and here we have a spread of about 110. So we're going to go with B having the greatest spread as well. Okay, so the point being, even without data, you can figure out measures of center, measures of variability, which one's larger, smaller, and what you might use as a measurement for both of those things based upon the types of data that you have. Okay, so when you have measures of variability for a data set, you can either calculate them or you can estimate them based upon a data display. When you look at variability, you're talking about the spread, how spread out things are, and you have to decide whether things are symmetric or not to decide whether you want to use the mean or the median. You're looking for things that are skewed or outliers and things of that nature. Okay, so hopefully that helps you with today's lesson. So in summary, to compare data sets, it's helpful to look at the measures of center and the measures of variability. The shape of the distribution can help choose the most useful measure of center and variability. When distributions are symmetric or approximately symmetric, the mean is the preferred measure of center and should be paired with the standard deviation as the preferred measure of variability. When things are skewed or when there's outliers, we want to use the median for the measure of center and paired with the interquartile range as the measure of variability. Once you know which one you want to use, you can start using those to figure things out. All right, and these are some examples of which one you'd want to use for which different purposes. Okay, so the first one we can see here, we could use a mean, we could use a median if you wanted to, depends on which one you want to look at. Okay, this one's pretty nice for a median and interquartile range, no problem. Here, things are a little grouped together. You decide, right? So just some examples of things you might want to use based upon the lesson. Here's your cool down. Work on that with your class, and you're in your class with your teacher to see if you're getting it. So you can always pause it here if you wanted to. I'm going to move on to the homework for the day. All right, homework time. 20 students participated in a psychology experiment which measured their heart rates in 2 different situations. All right, so what are the appropriate measures of center and variability to use? What would we use? Well, the first thing we want to check is we always want to see, is there some sort of symmetry happening with the shape? That's symmetrical, that's symmetrical. And when they're symmetrical, what do we want to use? We want to use the mean and the standard deviation. Whenever we see some symmetry there, those are the ones that are the most appropriate. Now, B, which one shows the greater typical heart rate? Well, the greater heart rate, because we're looking at them being pretty balanced here, I would say that the mean is the typical. That's what we're talking about there. It's going to be about there at 90 for that mean. And this mean looks like it's right there at 85 there. So the greater typical heart rate is going to be in situation A. Okay. And variability, we're talking about which one has things more spread out, that's spread. Well, let's look at real quick here. If I just look at the terms around the middle, right, and the terms around the middle, I can see that for B, most of the things are right around the middle, which means that A also seems to have a little bit more spread, okay? That's one way of thinking about it. That could be the case, but we can also do the math on it, and when we do the math on it, we can say, well, this goes from 70 to 100. That's a range of 30. And here we're going 75 to 100. That's a range of 25. So based upon that spread there, we would say that B is going to be the one with the greatest variability, okay? And again, you could do that because of these little ones here. We can also spread things out. So you have to look at it. If you did the math exactly, you could figure out which ones are going to be. That we're going to go with B as the greatest spread just because of that distance of 25 compared to 30. So just keep that in mind. But if you got a rationale for why you think it's the other one, then be ready just to argue for it, okay? Number 2A, invent two situations that you think would result in distributions with similar measures of variability. So like two things that you would do where if you did two experiments, you get the same variability, okay? So it'd be something that would be very consistent in what you're doing, okay? So maybe you have a bag, and in the bag you have 3 orange little tiles and 3 red tiles, and you reach in and you pick 10, and then you do it twice, okay? Well, because they're pretty balanced for what you're going to have, I could probably get a very consistent or similar measure of variability because the odds of getting one or the other, it's a 1 and 2. So I would probably get something, similar displays each time, okay? So that's an idea. So you want something very consistent there. If I wanted to have one where I have distributions with different measures of variability, then in that case there, what I could do is I could say, well, maybe I have 3 bags, okay? And this one has 1, this one has 3, this one has a lot more, and then this one happens to have 1 and 1, and this one has just 1, and this one also has 1. And I let people choose which bag they want to put their hand in and grab one out of, and then I record the results after they pick 10. Okay, so pick a bag and then pick 10. That's going to give me very different results because depending on which bag they pick, I'm going to get different results. Okay, so you're changing the experiment up to get more variability. Number 3, the data set and some summary statistics are listed here. Here's our data in order nicely, 11.5 all the way to 21. We can see our mean, our median, standard deviation, and our interquartile range. How does adding a 5 to each of the values in the data set impact the shape? So if every value was plus 5, plus 5, plus 5, plus 5, is there any change to the shape? Okay, so if you think about this shape, and we wrote an 11 there, a 12, 13, 14, 15, and so on, I just have like little dots like this, right? 15, 16, 17, 18, 19, 19, and 21. If everything became 5 more, then this became 16, 17, 8. Nothing changes the dots, does it? Everything, the dots just shift over to the right. The shape shifts to the right 5 places 5 values. That's it. It looks the same. It just moves on the number line where it's going to be. Okay? What if I add 5 to each of the values in the data set? What's that do to this measure of center? Okay, well, the measure of center is also going to be moving over. It's going to increase, in that case, by 5. Okay, it's going to increase by 5. So if the measure of center was over here, now it's going to be, instead of 16.7, we would say it's now 21.7. So it's going to move 5. Okay, how does it impact the measure of variability? It really doesn't have any impact because it's going to be consistent. Because I'm doing the same thing to both things, the measure of variability really isn't going to change at all. Okay, so that's what we would say for that one. All right, box plots. Number 4. All right, which one has the greater median? All right, so the median's a line. We're at 105 there, and we're less than 105 there. So the greater median is going to be at A. Greatest measure of variability, well, here we're starting at about 97 and going up to 115. Here we're about 96 and we're going to maybe 113. Okay, so in terms of like how far out the numbers are, there's not a huge difference there, right? But remember that this here represents 50% of all the values are inside of this box. So most of the values are inside that box. So for A, half the values are in the small little section there, and for B, half the values are spread out there. So that's why I like to look at the values between the Q1 and the Q3. So most of these values are pretty spread out away from the center there. So for me, I'd probably go with B has the most variability because I can see half the values are more spread here than they are over here. Number 5, the depth of 2 lakes is measured at multiple spots. For the first lake, the mean is 45, standard deviation of 8. For the second one, the mean is 60, standard deviation of 27. Noah says the second lake is generally deeper than the first. Do you agree? Well, so here's lake 1 and here's lake 2. The mean is 45 here and the mean is 60 here. So the average is definitely deeper, but you do want to look at standard deviation, right? This one can be plus or minus 8 for standard deviation. This one here can be plus or minus 27. So while you could subtract 27 and find some low spots in number 2, you can also find some very deep spots, up to maybe 87 feet deep. Here, the deepest spot might be only about 53. So would you agree with Noah? I would agree that generally the second one is deeper. Number 6, the dots display the height rounded to the nearest foot of maple trees from 2 different tree farms. All right, so we have some nice symmetry happening here. Some nice symmetry happening here. Okay, compare the mean and standard deviation. Well, the mean of this one's right there at 8. Because of the way this one's spread apart, it's also right there. So the means are equal. They're both at 8, okay? But the standard deviation is going to be less for that one and more for that one. So if we called this A and this B and looked at standard deviation, we would say that A has a smaller standard deviation than B. So what does that tell us about the trees? Well, what it tells us is that overall the average height's about the same, but B has a greater variety, okay, of small trees and tall trees. We can see 4-foot and 12-foot. There aren't any 4-foot trees over here or 12-foot trees. In A, they're all a similar height. In B, they're spread out more, so more variety in the B trees. And number 7, getting to the end here, which box plot has an IQR of 10? Which one has an IQR of 10? Interquartile range of 10. So that's going to be the Q3 minus the Q1, right? And so when we look at those, we have to see which one actually is 10. So here we are at 12 and 1.5. 12 minus 1.5 is not 10. Here we are at 12 and 9. That's going to be 3, so no. Here we are at 12 and 2. 12 minus 2 is 10. Looks right. Double checking over here. Here we have 9 and 6. 9 minus 6 is 3. So no. 1 with 10 works the best. And finally, number 8, what effect does eliminating the lowest value, -6, from the data set have on the mean and the median? So if I get rid of the 6 and make that go away, what is going to happen? Now, I think they want you to figure it out mathematically and do some math on it. But in general, what will we say? I'm going to say that in general, with the mean is going to increase because I got rid of a small number. And that for the median, I can look at that one. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values there, which means that before my median was over here at 4. And now that I got rid of the 6, my median is going to go up to 1 to the value 5. That actually becomes the middle now, right, with 4 on each side. So it's going to increase by 1 to go up to 5. But the mean is definitely going to go up more than 1 because that value is going to skew the data to the left. Now it's all going to be a little more balanced, and we'll get a better mean. That's it for the day, and possibly it for this unit. Have a great day, and we will see you next time.